Our topic will be Roots of KBE, leveraging CATIA V5 common knowledge tools using automation. Our presentation today is scheduled for about 45 minutes. It'll be concluded with a question and answer session. You could submit either your questions via the WebEx or hold your questions for the end. We'll be placing all the lines on mute, so at the end of the conference, we will unmute all the lines for that question and answer session. For those of you in attendance today, one lucky winner will receive a chance to get a 3D Connection Space Pilot Pro. That will be awarded this week, and you'll be notified via email if you are the winner. Okay, today's presentation is being delivered to us by Bob Garrison from IDEX Solutions. Bob is the Director of PLM Technical Services at IDEX and has been at IDEX for the last 2 years and has spent about 20 years in the CAD/CAM world, using primarily CATIA V5. And we have a special guest today from Parker Aerospace, Brian Spellman. Brian is the Engineering Systems Administrator for the Aerospace Group in North America, and we're pleased to have him here. We'd also like to give a very special thanks to our advertising partner at Connect Press. Connect Press is the industry-leading publication available online. You could visit their site at www.connectpress.com. Okay, just a little bit about IDEX Solutions before we get started. IDEX, we were founded 15 years ago. This year we're celebrating our 15th anniversary. In just a few days here will be our 16th year. We have customers of all different sizes. We primarily work with a lot of the small to medium businesses and help provide services to some of the larger Tier 1 and OEMs out there in the aerospace and automotive communities. We have a specialty in PLM, implementations, training, and product customization, and we also provide a wide variety of engineering services. Okay, what I'd like to do is I'd like to hand it over to our esteemed colleague from Parker Aerospace, Brian Spellman.
Hi, as I guess you just heard, I'm Brian, and IDEX has asked me to give a short presentation on how we've used KBE and CATIA automation here at Parker. I'll begin with just a short background on Parker Hannifin. We're a worldwide manufacturer of motion and control technologies. Our headquarters is in Cleveland, Ohio, but we have 142 divisions worldwide and 58,000 employees. The Parker Aerospace Division is a global leader in flight control, hydraulic, fuel, and you can read all of the different areas there. And we're headquartered in Irvine, California, and have about 6,000 employees with 8 divisions and 43 locations. This next slide will just give you a quick overview of some of our clients. And the automation projects that we've done are actually at quite a few divisions. For the presentation today, I'm just going to talk about 2 of our divisions, Control Systems Division and the Electronic Systems Division. At the Control Systems Division, we had a process that would take several months to complete from start to finish. At least 5-6 months just to go through this process, and was, as that lets you know, quite time-consuming. The idea was to come up with a rapid manifold design tool in order to allow us to have consistent structure for every design, to embed the calculations that were made with V4, to use that same thing into CATIA V5 with built-in check-ins to allow for the model, such as minimum thickness and cavity interference, to also be able to embed the circuit flow architecture that's used in the manifold, and to allow for configuration changes using parameters to be able to quickly change what type of holes and various features were used on these, and to give design flexibility and integrity. We also needed to be able to allow for the conformity of the holes with the stress factors and to level the best practices that had been developed over Parker for this manifold design. And this process had to be standardized in order to allow really any of the designers and users to use it and to give the same look and feel for the models no matter who was developing it. So we were able to take the process that took several months and in the hands of some of our designers down to just 3 or 4 days to be able to complete this. See on this next slide, which seems to be missing 2 pieces of it. There we go. Okay. We're able to, you can see the process showing you in the top one how much repetitive tasks and redos were used in this, and been able to use both our lean process development and then the KBE and automation to greatly reduce that time. And as I said, we were able to take this process from months of use down to mere days. So that was one example of the successes we've had with automation. Another one is at the Electronic Systems Division, and here we actually just had a month where IDEX was on site helping to develop automation and KBE tools for the guys over at that division. And several areas were greatly improved, one of which was our Fuel Probe product line, where we now have a product duplicator script that will allow for the existing models to be reused, since a lot of the work is able to be duplicated, just to reuse it with a script that will copy the existing model, rename the file name and the parameters, the part number, the instances, and just allow it to quickly be modified into the next model. And this actually spurred an interest in not only a script to reproduce these models, but to do the same thing for just generic products. Another area was with the drawing automation tools. We now have a script there that will allow us to create a drawing directly from a part or a product and to eliminate a lot of the normal processes that we'd go in through the standard way of having to create a 2D drawing. Using this process, we now have the parameters that were entered into the Properties tab of the part just happen to be populated automatically into the drawing, such as the drawing number, the title, the used on, who it was drawn by, current date, all the information you'd have on the drawing put in there automatically straight from the product or the part. And to also create or transfer the parameters straight to the drawing, as well as a tool that will do this same thing for legacy parts and to add the parameters needed to those drawings and models. There's also a drawing sheet tool that can go in and rename the number of sheets, rename and count them, and correctly identify the sheet numbers. And then we had one other area that was used at the Electronic Systems Division for automation was with our electrical harness aids. The problems with the process that we had there were a lot of redundant and time-consuming operations. In order to just make sure that the measurement inspection points of the flattened 2D harness match that of the 3D model, and to be able to give all these measurements to the client. There wasn't actually any paper trail of how all the end calculations were made, which is something that the clients wanted to be able to see. And the check-in and cross-checking process was repetitive and prone to human error. The attributes for the reference designators in the 3D harness model were being transferred manually from the model to the next model prior to flattening. And this is another process that was prone to error and quite time-consuming. And the same thing can be said for just the way the process worked in general, with a lot of repetitive process and time-consuming and human error. So we now have tools and methodologies that were implemented to reduce the redundant operations and help provide accurate information, and to have a history of how all this was done. We have new methodologies there to give us a consistent structure for the geometry and to give a 3D schematic that is linked back to the harness model. And there are now macros in CATIA that allow us to generate a CAT part that has all the structured set of the bodies used to create this. Also producing a CSV table with all the different measurements needed between the segments, and to transfer all this information to a flattened model. So the team that Bob worked with over at Parker was originally not the greatest fan of this CATIA product, and after the time that IDEX spent there, as you can see from this quote, they think the CATIA is actually pretty cool now. So with all the automations, a lot of which happened from the KBE workbench, we're able to improve both the time it takes and the user experience with CATIA.
Great, thanks, Brian. At this point, we're going to turn it over to Robert Garrison with IDEX Solutions.
Thanks, Brian, and thanks to Bond for the introduction. So let me switch us over to CATIA. The development work that took place at Parker Electronic Systems Division and here at CSD, and actually with a lot of our customers, was on earlier releases. So in a stroke of boldness on my part, I removed all of my CATIA off the laptop that I'm using for this demonstration today and installed release 21. So I did a quick cursory check of this last night. We'll see how well the demonstration goes. Part of what has taken place with all of these automations has its underpinnings in just normal CATIA. Some of you may have attended the Roots of Common Knowledge webinar that I did last year, where I discussed this topic pretty extensively, and I'm going to at least point out some of that today, but most of it I'm going to skip over in favor of just showing you some of the automations that have taken place with Parker and with some of our other customers. I will not be showing the rapid manifold design project today because that is highly proprietary to what Parker does with their machined manifolds and the assembly of those manifolds. But that project was quite lengthy in duration. Development was done almost entirely in VBA, and really a lot of that is using these tools that we see here, the common knowledge tools that are available in any workbench of CATIA, along with a subset of the Knowledge Advisor workbench. But really, these tools here are your fundamental tools in getting into KnowledgeWare and KBE and CATIA. I imagine that many of you by now, especially the experienced users, have built formulas and built design tables and equivalent dimensions and so on and so forth. So I won't belabor these or how those are built. I'm going to show how they're deployed in a slightly different fashion than manual interaction. In concert with this common knowledge tools is obviously the structure of the tree itself. And that structure can be just a normal array of standard part bodies and geometric sets, which probably a good 70% or more of the V5 user community are deploying. But it could also include things such as ordered geometrical sets or hybrid bodies being bodies that could contain both solid elements as well as wireframe and surface elements in a structure that requires you to have a defined order of work objects and so forth. So there's a very well-defined parent-child relationship. In projects like the RMD project that Brian mentioned, as well as any automation projects, the structure of these bodies, how you build those manually in concert with any of the knowledge that you build, in order to leverage that through automation, has to really be structured consistently in every single part. and in every single product where the automation is being applied. So in that sense, if we were to come in and take a look at how we might deploy that, there's a number of ways. You could build a start model and have people do new froms and all of that type of operation. What we've done is leverage the Visual Basic Editor in CATIA to consistently deliver the types of tools that, or the types of structure that we may need. So I'm going to show a little bit of what we did when we were out at Parker Aerospace in Long Island at the Electronic Systems Division, because some of that's not proprietary, and I don't think that ESD has much of a problem in showing that, but there'll be other things that I won't be able to demonstrate to you in this, but this will give you kind of a feel. So I was talking about delivering a consistent structure. So based on these requirements that Parker had to measure wire harnesses, they really needed to have a part that was structured with specific syntax and specific bodies to be in place. So I actually built several macros for them that do that. One was to go in and actually just build the part that would be used to contain the harness length. So if we were to run that particular macro, you can see that it gives the designer some information about the harness itself. So this might be Airbus left wing harness as an example. And the designer actually has a schematic, a very simplified schematic that shows every bundle segment in that wire harness and numbers it with a specific number. So we need to know by looking at that segment exactly how many, or that diagram, exactly how many segments are involved. So let's say that this one had 30 segments involved in it, and that's all the designer would have to do. The automation would then go and build the structure for them. Now, there's some manual operation that takes place at this point. This part, this Airbus left wing in this case, would actually get assembled into the same product structure that contained the actual wire harness. And when in that product structure, this would become a contextual part with some extractions of the centerline segments into this model. In some cases, they may need to manipulate those references, so there's a delivered body as well for the manipulation. So that would be how the starter part would be created. Now, let me just give you an example of one of these harnesses, and we'll take it a little bit further along. And actually, even let me bring up the product for this as well. This will take a moment to load because it's quite busy. So while this is loading, just to let you know, all the electrical harness design work was being done outside of ESD. So really what was happening inside of ESD was the responsibility to manufacture the harness. So that meant they had to do the flattening and all the other operations that went with it. So these would be connectors that my apologies for that interruption. So these would be all the connectors that connect to the fuel probes that Brian Spellman had mentioned earlier was another automation project that we did. So these would be the connectors, and the harnesses would be where they would take off from, and they would network around. And so this is what the engineers and designers at ESD would receive. Well, you can see that incorporated into this product structure now is the actual segment and manipulated references and so forth that came from that first macro that I showed you. And so basically the designer could then walk down based on the diagram and the harness itself and get all the center line extractions that we see here, which belong to these harness measures. So let me close that for a moment. And you can see also by the green gear here that that's a contextual part. So this would be the manual intervention part of this, just the designer making some decisions of where a segment begins and where it ends based on the schematic. because these designs were coming in from their customer in a variety of ways that weren't always consistent. And what they really needed to know was what these lengths were in order to cut the wires and to lay it out flat on their manufacturing tables. So in the original process, when I first came out there, they were actually going down through these diagrams and using the measure tool to come through and create all these measurements, and then taking these measurements. Let me take and turn on one of my options that was off. Now, so they would take these measurements and manually transcribe those into a spreadsheet, and there was a lot of errors that were happening with that transcription process. Okay, so they would have these, and they would go ahead and transcribe these and walk this down, and then there was a lot of back and forth as to what these actual lengths might be, and a lot of discussion back and forth with their customer. So when I looked at this, I found that these use of measures, which a lot of clients of mine have done in the past, was a bit redundant. So I suggested that we just go in there and take all those measures and abandon that repetitive manual task. Get rid of it entirely, because we've already captured the segments themselves, and the segments contain an element, in some cases a join, in some cases a split, but it basically contains the elements that comprise the segment lengths, and then we'd run a second macro against this. Now these macros I'm running by going to the macros toolbar. We actually built toolbars for them that they've deployed into production, but in this case, let me close this for just one moment. So if we look at this, you can see there's a curve there, there's a join, you know, the typical parameters that come with that, but no measurement of length. So basically, this other macro that we developed for them would come in and take and get those segment lengths. So if I run this, this program now does a number of things while it's processing. It's going down and looking through this well-defined structure of segments in the wire harness. It's grabbing the geometry in each one of those segments, and then it's producing an output in an Excel spreadsheet, which is the way they wanted this displayed, which gives them, based on each segment, what the length of that segment is in inches and in millimeters. So depending on their customer requirements, they could go with one or the other. Furthermore, if we come in here, it's not just extracting that information in the way that you might expect, but you can see up here that there were a number of formulas built. That was built by the automation as well. And if we go into any one of these segments, the designer now, rather than using the measure tool, can see the measurement of that curve based on its parameterization and the formula that's using a measurement of that curve. So this was extremely robust for them. It took a lot of pain out of going through and using the measure tool to capture that same kind of information. Now, an extension of this, I'm just going to open up another spreadsheet here in just a moment. As an extension of this, I had an engineering manager who would then say, well, that's great, now I have all those measurements, but I need to calculate based on, for QA purposes, calculate some additional information. So I'll show you that one here very quickly. I'm just navigating to that file right now. And let me go ahead and share this with you. So in this case, you can see that over here in the left-hand corner are all those segments that came out of CATIA. And basically into this macro-enabled workbook, the engineer would just copy and paste this column from that output from CATIA into this macro folder or into this macro column. And then what they're interested in for QA purposes was the cumulative length in the 3D model. And also, in some cases, they were going to add some additional length based on some connector types. So the users could actually, or the engineer could go in and change these names to whatever name happened to be referenced. So if I came into, let's see if I can remember how to use this one now. If I came into this column here for my segments used, and I said that I was using segment 1, 2, and 3 as an example from this this item, and actually let's go up to our macros, calculate cumulative. So actually I should come over here and take that one out of play. It's always amazing to me how you can write macros and not use them for a couple of months and then forget all about it. So I'm going to say that segment 1 is actually going to be from segment 1 and 3 and 4 from that schematic that we were talking about. And I'm going to add 2 type 1 connectors, one on either end of that segment. And then I can go ahead and do a calculate, and it will calculate the cumulative length of segment 1, 3, and 4, which is what they needed for QA. It also documents for them which segments were used in that process. And for manufacturing purposes, there were additional length added, which was 2 of these connectors here. So this now gives a full historical record, if you will, to go back to the customer when the customer says, well, you know, the length that we're showing from our design is you're off by 150 millimeters, let's say. Now Parker ESD can have a full breakdown of exactly how they're getting their manufacturing lengths. And so oftentimes this gets now pushed back to their customer as some calculation or miscalculation on the design end rather than being a problem on the manufacturing end. So this kind of tells you a little. We also wrote some other ones that dealt with the flattening module of for the wire harness flattening from that 3D model I showed you earlier. But this kind of tells you a story of a structure, then rolling out to an Excel workbook, and also rolling out to reporting capability. So I'll close this, and then I'm going to talk a little bit about some of the drawing automation. This is, as Brian had mentioned in his presentation, there are a number of divisions that are at Parker Aerospace Group, and some of those we've written macros for that are related to drawings. In some cases, some of the divisions have actually started writing their own, so there's a variety of different drawing generators coming out. I think in the coming year, one of the initiatives that Parker Aerospace has is now to go to all these disparate groups and say, okay, each one of you has got some form of a drawing generator that you like and works for you. We want to try to take and consolidate all of that activity and make one universal drawing generator for every division in the group that accommodates each division's needs as well. So I think that's the next step up from this process. For those of you that are in the audience that belong to companies that have multiple divisions, you may have seen some of this kind of creep exist as well. Here, let me go ahead and okay, so here we go. We'll open up that library. So in the drawing sheet generator, basically what we built was a toolbar that contains all of these, or most of these VBA programs that you see here, some for handling the generation of a drawing, some for handling sheet renumbering, rescaling sheets, populating parameters, things of that nature. So let me go ahead and close this out for a moment. And one of the issues that they ran across at Parker ESD was that in some cases they had parts that were legacy parts. So as many of you know, you can create parameters using user parameters here, which would show up in the tree. So if I created one of type real here as an example, it would show up at this location. However, there's other parameters that show up under product properties, which were equally important for the drawing purposes. And when we come in here and take a look at the product properties, part number, revision, nomenclature, some of these Parker ESD was using. And I've actually written a number of these macros, variations or flavors of these for other customers. And then also there's other properties that may get assigned to these parts. For instance, I may want to assign a string type parameter, and we might call this supplier as an example, and then some piece of information that goes with that parameter, whatever that happens to be, and that would show up here. Well, Parker wanted that information stored at the product and part level, but also to appear on drawings in drawing parameters and also in title blocks and things of that nature. But if they had legacy drawings, oftentimes these parameters were missing, and so the question became one of, well, how do I update my legacy drawings? And so we wrote a little macro to go do that, and I'll go ahead and run that. That was the one for populating 3D parameters. So if I just run that, it comes in and tells the designer that 4 of the necessary parameters were added to the product properties. And if we come back in and take a look at that, properties at this point, you can see that what they were looking for was drawn by, system designator, next assembly, and what it's used on. And now all they need to do is come in and edit that data. Some of this was being populated, some of this data here, like revision, for instance, and some of the other was being populated from their PLM system, which was earlier version of Matrix 1, which is now being migrated into Anovia V6. So this information is not always populated manually. Sometimes it does come from their PLM system as well. Let me close this one out. Let me just open up another document. I think I have a test part in here, which I'll just use for our purposes rather than using some of their data, because their data, as you might imagine, is fairly proprietary. I could get away with showing you that harness, but some of the other data I can't really show you. So in this case, if we come in and take a look at the properties on this one, you can see that this already has some parameters in here. Some are missing. This is just some junk data in terms of part number and things of that nature. They have a distinct part numbering scheme here with which has a 02D or some other 3-character designation followed by an underscore. And so in this case, they wanted to parse that part number based on those rules. So this macro is pretty specific in that regard to the numbering scheme that's being used at ESD. So one thing that I need to do in here is kind of concern myself that those parameters were missing. But if I come in and run my drawing generation macro, we'll run that drawing generator, and it tells me, well, there's some parameters that are missing from this part. So I need to correct that before I can proceed. So this pretty much blocks the user from generating. Oh, those aren't being shared, are they? Let me do this. Yeah, let me share, let me just share my desktop, and hopefully you'll be able to see everything. You guys should have said something to me about that. How long has that been going on? Okay. And now I'm not seeing CATIA. So let me click OK here. All right, now we're back to CATIA. So you saw that little message that came up. So obviously, at this point, if I come into my macros, what I need to do is come in and populate my 3D parms in here. So we'll run that again, and this time, since 2 of them were already present, it just tells me it added 2 more to the mix. Okay, so now we'll go and run the drawing generator. and it says, well, you've got those parameters, but they have empty or invalid values. Do you still want to continue? And I'll say, yeah, I'd like to continue anyway. And at this point, we look up some predefined formats. So the designer picks the format size that they want. I'll go with the C-size format in this case. And then the program takes off from there. Now, there's actually, in this case, to define what is the initial view for this, it actually uses a camera within the 3D model. That was the methodology that we agreed on in this case. So it goes ahead and arrays these in, and it looks for a basic view scale that fits within the drawing sheet that was selected. And just to point out that more than just those initial drawing views, it also populates these parameters with all that information from the 3D model. Now, in this case, we're not actually linking these parameters to the 3D model because the designers out there wanted a little bit flexibility to maybe override what was in the 3D model, but even beyond that, they didn't want to have to deal with the extra parameter multi-model linking that was going on. So we actually wrote a second program, which I won't demonstrate in this session, but it will actually synchronize. It looks for the first generated view in the drawing, finds the part or product that it's associated with, and will synchronize these parameters with the parameters that we just saw in the 3D model. So there is a synchronization feature built in, but it doesn't bind the user or handcuff the user by creating the multi-model links. The other thing is that there's some view scales going on here. This is a 1 to 8 view scale, so the designer may not want that. So if we come in and look at our complementary macro here, which is to rescale all views on the drawing sheet. So if we run that, it's going to ask what scale do you want. So maybe I might want to go with a 1 to 4 in this case, and it rescales all views on the sheet. And if that's too large, then I can also go in and adjust it accordingly. Down here in the title block area through attribute linking and some programmatic interface, it's coming in and now populating the title block, populating sheet numbers, and so on and so forth. As the designer continues to create additional views and additional information, and perhaps they use it in this fashion, so we'll do a copy and then a paste of that drawing sheet. We get another sheet and another sheet, and you'll notice each one of these sheets now is sheet 2, or perhaps later on they came in and manually updated this and deleted one of these sheets, and so on and so forth. And even in the title block area, if we come down to this one, you can see that it didn't update this information here or here or here. So we just wrote a simple macro that's looking for named features or named text features here that come in and take care of that population. So that's the drawing sheet renumbering. And if we go ahead and run that, it goes through and processes all those sheets. And you can see that now the sheet numbering is all correct on every one of these sheets. And also in the tree, they've been renumbered as well. It ignores detail sheets, obviously. So this is just some of the defined structure delivered through automation to make the designer's life easier. Just a little bit in summary, because I'm getting towards the end of my time for this today, but there were 2 of us that went out to Parker ESD, myself and my associate Wes Russell. And Wes spent 2 weeks out there, and then I spent a solid 4 weeks. And actually, it was kind of nice working for a company that's a value-added reseller. Typically, we jump around from place to place and spend no more than a couple of days at a time with a customer or with a prospect. So this was kind of nice to settle down with the design group for about a month that I was there. And a lot of what you saw with the harness work was actually spur of the moment. It wasn't on our original schedule, and I just happened to see that there were some really redundant and error-prone operations going on. And so I started talking with the engineering manager, and he showed me his nightmare in the Excel world. And over the course of 5 days, we stitched together a really good methodology for them that significantly reduced the time that it took to get the information they needed, and also provided a paper trail that didn't exist prior to that. So that concludes the demonstration. What I'm going to do now is unmute everybody that's on attendance, so give me one moment for that. And now everybody is unmuted, so I encourage you not to all speak at once, but if there are any questions from anybody out there, please feel free to ask them now.
Are there any questions out there? Okay, I think you guys did a very good job of outlining the robustness and the power available through the KBE tool for CATIA. Obviously,
hold on one second here. I thought there was a question. There's not.
I think with you sharing about the amount of time you spent out at ESD, along with the time that it actually took for you to develop the code, I think that helps everybody get a fair understanding for the type of effort this entails. Obviously, the more redundant the process, I would say it's a very good qualifier for having to look at KBE tools to help refine that.
I just noticed going down through the chat log here that there were a couple of questions. One was that some of the windows that popped up, I wasn't sharing my entire desktop, but towards the end I caught that. So hopefully some of the dialogues that were blocked out as a yellow square, you did see those. I did notice that the macro panel itself didn't show up, and I think that was a function of the WebEx, so I apologize for that, although I have no control over that. And hopefully I did share the Excel spreadsheet, so hopefully you were able to see that macro-enabled workbook towards the end when I did share my entire desktop. And then finally, towards the end, there was a couple of questions from Paolo Lorane, and he was asking about the development of that wire harness set of macros. So first of all, one question that was that all VBA, or was there some CAA in that? All of the functionality that you've seen today, which is small in scale, but all of that functionality was developed in VBA, not in CAA. There was no CAA involved in that. In terms of the rapid manifold design project, which we didn't demonstrate, but which Brian talked about, almost all of that was VBA as well. There was probably a very minuscule part of that, which was a DLL built in CAA. So that all that functionality is available to you in VBA. As far as the amount of time that it took to develop that code for all of that harnessing activity that you saw, and bear in mind that some of that harnessing activity was a user intervention as well, to make some decisions about where segments began and ended in the 3D model, but all of that development work was done within 5 working days on site. And okay, another question came in from there was more than the requirement for more than 3 basic views to be populated on the drawing. I kind of jumped in at the end of that very quickly, but the answer to that is yes, there were more. There were some detailed views, there were some broken views, and other projections, but they wanted to start with just 3 basic views to be generated automatically, and then to go and continue with those other views on their own using regular CATIA functionality. The drafting API is not the most robust part of CATIA for Visual Basic applications, but there are some nice things in there for tables and bills of materials and things of that nature. But the view generation, they wanted to have a little bit more control on that. One of the things that I didn't talk about in the presentation, weren't aware of, and they were leveraging pretty heavily by the time I left, was using the generate dimensions function in CATIA drafting. Many users do not leverage that, but actually in the 3D model there were some measure constraints that were implemented, and it made life easier for them when they turned on the filters before generation and used only measure constraints. They got exactly the dimensions that they wanted using that functionality. I didn't show that today. Perhaps in a future webinar I can show you that. It's a very overlooked functionality in drafting that's extremely powerful.
Okay, I think that concludes our webcast for today. I'd like to thank both Brian Spellman and Bob Garrison for taking the time to share with us this afternoon. I also wanted to remind everybody about our next webinar. Check your emails. You should receive a notification about our next webcast, which is Delmia V6 NC Machining Overview for 2012X, the enhancements in V6. So we look forward to that, and you'll have also another chance to win a Space Pilot Pro. And again, thank you everybody for joining us this afternoon. We'll talk to you next time.